Hello, and welcome to our tutorial video demonstrating the integration of the Neuro Omega neuromodulation system with BCI2000. In this video, we will discuss the benefits of using the Neuro Omega in your experiment, followed by a tutorial on implementing the neurostimulator with BCI2000. BCI2000 is an open-source, multi-purpose software tool for real-time biosignal acquisition, processing, and feedback. BCI2000 is very adaptable and can accommodate a wide range of neurophysiological experiments, including simple stimulation presentation tasks, neurofeedback tasks, and brain-computer interface experiments. Additionally, it is very easy to add peripherals such as a webcam or motion trackers. The Neuro Omega system, produced by the company Alpha Omega, is designed for use during a deep brain stimulation procedure. The Neuro Omega contains 122 channels and has a real-time subthalamic nucleus navigation. It can both record and stimulate the channels simultaneously, which can be controlled programmatically through BCI2000. To connect to the Neuro Omega from your PC, you will need to download the Neuro Omega Software Developers Kit, or SDK. Unfortunately, this SDK is not accessible to the public and cannot be found online. However, if you have a Neuro Omega device, you should have access to the SDK. Contact Alpha Omega if you need it sent to you. The only physical setup between the two systems is the Ethernet cable. On the underside of the Neuro Omega, there are 3 Ethernet ports, but one is usually extended for easy access. Plug it in and connect the other end to the BCI2000 PC. There are 2 configuration settings that must be specified when connecting to the Neuro Omega. The first is the IP address, and the second is the MAC address. The PC's IP address needs to be configured such that it is on the same subnet as the Neuro Omega. This can be done by checking the IP address on the Neuro Omega system Ethernet adapter and setting the BCI2000 PC's Ethernet adapter to an appropriate IPv4 address and the same subnet mask. Change the BCI2000 PC's IP address to exactly match the first 3 numbers, then put the 4th number as an integer between 0 and 255 and not equal to the Neuro Omega's number. Then change the subnet mask to exactly match the Neuro Omega's. You will then need to know both systems' MAC addresses. On the Neuro Omega, there is a sticker on the bottom that displays its MAC address. On the BCI2000 PC, enter ipconfig/all into the command line. Scroll to the Ethernet adapter section and find the physical address. This is the MAC address. These are necessary BCI2000 parameters, which we will later show where to enter them. For now, to confirm that the 2 systems are connected, try pinging the IP address of the Neuro Omega. If there is no response, make sure the Ethernet cable is connected and the mentioned addresses have been changed as specified. BCI2000 runs by executing batch files. In the batch file that you are using, make sure Neuro Omega ADC is the signal source executable, which is the first one. If you are stimulating, append enable Neuro Omega stim equals 1 to the same line. Since the Neuro Omega can both record and stimulate, we will first review the recording parameters and then the stimulation parameters. These signal source properties are included for any signal source module. However, there are a few technicalities uniquely relevant to the Neuro Omega which should be discussed. First, the sampling rate. The specified sampling rate must match the set sampling rate on the Neuro Omega. This is set by choosing the correct workspace template. To create a new workspace template, click on Workspace Template on the Neuro Omega, then create New Template. In most cases, just press Next on this page. You can then change the array parameters based on what is desired. The high frequency is 22 kHz, while the low frequency is 1.375 kHz. You can also change the number of channels that are sampled. Then click Map Channels to save the changes and view the mapping on the right side to confirm it's what you desire. Now, when you are setting up the Neuro Omega, choose this workspace template for your experiment. Once you start the operation, you can press Ctrl-Shift-M to view the options bar. Go to the channels you want to sample and make sure they are viewable with the correct sampling rate. If it is empty, it means they aren't being recorded. Make the sampling rate parameter in BCI2000 match what is specified here. Also, the channels and recording channel IDs parameter must also match. When you view the channels that are being sampled, you see that the channel IDs are in the second column. These are the only channel IDs that can be specified in the BCI2000 parameter. Right underneath is the hardware addresses section. Thankfully, we already know how to obtain this information. Once these parameters are set, BCI2000 will be able to record from the Neuro Omega. The Neuro Omega stimulation parameters are split into two categories: the configurations and the triggers. The configurations define the shape of the stimulation, while the trigger specifies when the configuration should happen and which channel. The stimulation configuration is split into two phases, each with a specified delay, amplitude, and width. The pulse frequency and stimulation duration must also be specified. Then, if a train of pulses is desired, the train duration and frequency can also be specified. The stimulation triggers contain an expression, a configuration ID, a list of channels, and a return channel. The expression must be a valid BCI2000 expression. For example, stimulus code is equal to 1. When this expression is true, the stimulation specified by configuration ID will be triggered. The number corresponds to the column number in stimulation configurations. It gets delivered to the specified channel, and if there is a list of channels, it gets sent simultaneously. The stimulation is then received by the channel specified and return channel. Use -1 to use the universal ground as the return channel. To show the stimulation in action, pre-configured parameter files have been loaded into BCI2000. We should see stimulation bursts of 3 pulses at a time. Since nothing is connected, the stimulation looks different than how it normally would, but even so you can still make out 3 distinct pulses from BCI2000. When observing the Neuro Omega visualization, it is nearly impossible to gather any information real time. If a signal is noisy or an electrode isn't connected, BCI2000 will be able to give you that feedback immediately through the visualization, which otherwise wouldn't be figured out until post-experiment. This gives you the chance to fix a connection before the experiment is run, which will restore the unusable data. Without BCI2000, the problem would not have presented itself and would have remained unfixed. If the stimulation parameters are too confusing, worry no longer because there is a GUI to help you out. This MATLAB application makes creating the stimulation parameters very easy. On the left panel is where you specify the desired parameters. And then click Update Graphs to visualize the stimulation from 3 viewpoints. Once you confirm the stimulation is how you like, click Save Configuration to update the tables in the panel on the right. Before you export the parameters, you must add the MEX file, Convert BCI PRM. Click on the Add MEX Files button, then navigate to the folder where this MEX file is. Then to save the parameters, click on the Export button. This will save the tables that you have on the right as valid BCI2000 parameters files. You are now prepped with all of the information you need to add the Neuro Omega to your experiment. With a couple of simple steps, the Neuro Omega neuromodulation system can be implemented in any experiment in BCI2000. If you have any lasting questions, please refer to the Neuro Omega informational page on the BCI2000 wiki. Thank you for watching our video.